Hello students, today we are going to learn Coulomb's law. Basically it's a part of electro 1, it's the first topic of electro 1. In Coulomb's law, we have to study interaction between the charges. Basically, you have a feeling of repulsion like positive repel, and you have a feeling of attraction where a positive and negative attract towards each other, right? Now when what is basically we have to evaluate the force here, the repulsion force and the attraction force, the value of repulsion and attraction force, we have to evaluate that force. So coulombs, the scientist named coulombs gives us an idea how to find the magnitude of that force. Basically it's a law named as Coulomb's law. What? Coulomb's law. Okay. So what we have given the idea by Coulomb's law that let us suppose we have two charges. Here is Q1 and other is Q2. I have taken positive charges here. So basically they will gonna repel each other with a distance r, right? I think it's been a pretty clear. Okay, what is going to do it, what's going to happen here? These two charges gonna repel each other, right? So we have a repulsive force here and here, and this force is given by force on 2 due to 1, and this is force on 1 due to 2, right? So what we see, there are two positive charges, there is repulsion force, and repulsion force are given basically it's given that this charge is repelled by this and this charge is repelled by this. Okay, now here we can see, first thing we can see that two charges, basically two forces are opposite, they are opposite forces, right? And they are acting on a different bodies also, right? What if I told you they have same magnitude also? So first thing I said, opposite force, secondly on different bodies, and thirdly same magnitude. And we know that the force which have these three properties, inherit these properties, are called action reaction pair. If you remember, action reaction pair, any force to be called as action reaction pair, they have to satisfy three properties. First, they have to be opposite, they have to be on different bodies, and they have to be of same magnitude. I know you don't have such feeling of same magnitude, that's what I am going to teach you right now here. So Coulomb's law gives us an idea. What idea is that? He said the magnitude of force on 2 due to 1 is equal to force on 1 due to 2 is directly proportional to Q1, directly proportional to Q2, and inversely proportional to distance between them, square of distance between them. I hope it's pretty understood, right? And as if now you are of 12th, so I think you can rearrange them in a formula like this: F21 equals to F12 equals to Q1 Q2, oh sorry, it's directly proportional, remember, upon may r square, right? So basically force is directly proportional to Q1 Q2 by r square, right? So there is a basic property I am going to use here. If I remove the directly proportional sign by equal sign, means by this I have to put some constant here, so I am putting a constant here equals to Q1 Q2 by r square, right? And this constant has certain value, you have to cram it 1 by 4 pi epsilon naught q1 q2 by r square. Yeah, it's sound very cute, q1 q2 by r square. So on the next, what is this? This is 4, we know. This is pi, we know, 22 by 7. What is this? Epsilon naught, 1 by 4 pi epsilon naught. What is this? This is permittivity. What is permittivity of free space? Permittivity of free space, right? Ooh, what's this? I think you don't have the feeling of permittivity here. You know q1 is a charge, q2 is a charge, are there distance, you understand the formula, you have the feeling of gravitation here, gm1 m2 by r square, it's likewise similar to that in gravitation. But what is epsilon naught here? See, two charges, right? Read it carefully. Free space, permittivity of free space. What I am going to say, listen, two charges, two charges in free space are interacting, right? Two charges in free space are interacting. Suppose I fixed one, another one will accelerate in opposite direction freely, free acceleration, going apart, free, in a free space, going free with free acceleration. But what if I put these charges in a water? When I put these charges in a water, what will gonna happen? If I fix one and let the other move, the other is moving with the acceleration. Is it a free acceleration or there must be some resistance? Yes, there must be some resistance. There must be some resistance to the acceleration to that charge, right? So that resistance will be teaching it later on in a deep, in very deep sense. But here we can have a feeling of permittivity in free space, that this epsilon gives us the uh, think of freely charges in a free space moving without any disturbance. But yes, it has certain value. It has certain value, which is equal to 8.85 10 to the power minus 12, and got a unit also, which is going to be from this rearrangement. Like we have to take epsilon naught here and force here. You can see coulomb square, Newton comes down, Newton, and meter square. And now we can see that this is epsilon naught, put here, it's a constant, 22 by 7 constant, 4 constant, multiply 3 all divided by 1, it's a k. So we can give the value of k, you have to cram it, I'm giving it to you. This is 9 into 10 raised to power 9. And again the unit of this will be evaluated from this formula only. F is Newton divided by, this goes down, coulomb square, this goes up, so this is going to be Newton meter square, coulomb square, inversely basically, right? So 9 into 10 so 9 Newton meter square per coulomb square, and 8.10 to the 12 coulomb square upon Newton meter square. And this is what is the law given by Coulomb. So, and here we can now have a feeling of same magnitude. See, F directly proportional to Q1 Q2 by R square. Yani it is a multiplication of Q1 and Q2. Means this charge, this force on 2 due to 1 is the multiplication of q1 q2 divided by r square. F12 multiplication q1 q2 by r square. It means that these four charges have same magnitude. So where I can write, I am writing here, I think it's visible in the screen, I'm not sure, but first property I am going to say is they both have same magnitude. and I'm angry on that. Same magnitude. Secondly, forces are on opposite direction. We can see that, right? Forces are in opposite direction, right? Third, same magnitude, opposite direction on different bodies. On different bodies, yes or no? You gonna stand it or no? Yes or no? We have same magnitude, force in opposite direction on different bodies. It means what it means. It's an action reaction pair. It's an action reaction pair. Right. Now you have the full feeling that this force is an action reaction pair and its value is given by kq1 q2 by r square. And this law is given by Coulomb's law, and we have to follow this in every question. But it's not, we have to conclude other things, small things here also. It's not yet finished. So moving on to the next. No. You have to pause your video and write, please. I have rub it. Oh, sorry. Use this. I think this would be better. Sorry for the disturbance. Okay. Cool. We are going. Okay. Yeah. Yep. Till now we have understood the Coulomb's law. We have understood that this is an action reaction pair. Now moving on to the next. What next? Listen very carefully. I said that there is one student who read a book, and it's written in the book that Coulomb's forces, electrostatic forces, are action reaction pair, same magnitude, but action reaction pair, q both positive. So it says that same magnitude. So I said same magnitude, f, no problem. Second thing, opposite direction, good enough. The third, different bodies, on different bodies. It's act on a different body. But is it right? The student reads a book, he applied the formula, he made it, he write it, but is he right? You have a gut feeling, no sir, there is some disturbance, mistake, there's something clarity. Okay, I'll solve it for you. This is wrong. If you have a feeling this is wrong, yes, this is wrong. There's a scientist, he saw that and he's think about this in a deep and say we have to add something in the definition of electrostatic forces or Coulomb's law. There should be some definition addition to correct this mistake. So they said that Coulomb forces or these electrostatic force is a central force. What is a central force? It's a central force. Okay, then what is a central force? What is central force? Central force basically which is passing on to the axis only. Forces on the axis of line. This is this axis joining the charges. Forces applied or generated on the axis only are called central forces. So, what is electrostatic forces? First, it is an action reaction pair. Yes, okay. And other is it's a central force passing through the axis only. What? Force is passing through the axis only. Axis only, right? Axis only, right? Passing through the axis only, and it's an acceleration. Now this definition is completely filled. So what these two definition means, simply what we have drawn, this force R Q Q F21 F12. Now the definition is complete, and it's explanatory of this only. I hope my video is recording well. Let me check it's recording or not. Yes, it's in a recording. Okay, do you understand? You understand? Yes or no? Yes or no? Yes, we have to move forward. You have to answer yourself, do you understand or not? It's not for me, it's for you. If you don't, you have to ask me, so I don't understand it, please tell me again, explain me again, I'll explain you again. There will be no problem. Okay, now a basic property, a simple basic property. Without that, you're not going to solve any, not able to solve any numerical. So first property is acceleration pair, second property is central force, and the third property is now we are going to understand. Suppose there's a charge q1, there's a charge q2,